Okay, so to summarize what we've done so far this semester in 2 short weeks, week and a half really. We've seen 4 different methods to count votes: the plurality method, the board account method, plurality with elimination, and pairwise comparisons. And we've looked at 4 different criteria to decide if a vote counting method is fair. The majority criterion: if someone has a majority, they should win. The Condorcet Criterion: if someone wins all their head-to-head matchups, they should win. The monotonicity criterion: this is a revote situation. You have a vote and a revote. If the only changes are good for the winner of the original vote, they should remain the winner, right? Monotone, it should stay the same. And the independence of irrelevant alternatives criterion, or the dropout criterion, that's another revote situation. But this time, the irrelevant alternative, right, is that a non-winner drops out. Okay? If a non-winner drops out, the winner should stay the same. Okay, so make sure you understand those 8 things. They're summarized on page 9 of this packet. Let's take a look. I can show you where that is. This page is page 9 of your packet, and it has a summary of the 4 methods: plurality, board account, plurality with elimination, and pairwise comparisons, and then a summary of the 4 fairness criteria.
This so we can use on our test.
Yes, you can bring this with you to the test. Yeah. Because, I mean, just knowing, it's easy to get the names of the methods mixed up. So as long as you can do the methods, this can remind you which method is which. Okay, where was I? Okay, so that's something that you should spend time looking at and make sure that you are comfortable with those 8 things. All right, so even though some vote counting methods violate some fairness criteria some of the time, okay, our vote counting methods don't violate all of the fairness criteria. For example, is it possible for the plurality method to violate the majority criterion? If you're using the plurality method, so which one was the plurality method? Just remind me. Yeah, whoever wins, wins. Yeah, whoever gets the most first place votes wins, right? Okay, so if someone gets a majority of the first place votes, could they possibly lose if this is our method? No, because if someone has a majority of the first place votes, that means they have more than half of the first place votes, which means no one else could have more first place votes than them, right? Imagine an election with 100 voters. If someone has 51 first place votes, there's only 49 first place votes left. So even if another candidate got all of them, they still wouldn't beat the majority candidate. So it is impossible to violate the majority criterion if we're using the plurality method. How about pairwise comparisons? That's where we make all the head-to-head matchups: A versus B, A versus C, A versus D, B versus C, B versus D, C versus D. So you make all these head-to-head matchups, and whoever wins the most head-to-head matchups would be the winner. So that's a method of pairwise comparisons. The Condorcet Criterion says that if anyone wins all of their head-to-head matchups, they should win. So is it possible for someone to win all of their head-to-head matchups but lose the method of pairwise comparisons? No. So for example, AB, AC, AD, BC, BD, CD. So if we pick a candidate to be the Condorcet candidate to win all their head-to-head matchups, maybe we'll have B will be the Condorcet candidate. So B wins, B wins, B wins all their matchups. So that means B is going to have 3 1-3 matchups. So B gets 3 points. And then nobody else can get 3 points, because everyone is matched against 3 other players, and everyone will have lost at least once to B. Right? So B would have to be the winner if they win all their matchups. So this is a complete table that talks about the fairness of each method. Violates just means that it violates the fairness criteria in some elections. It's possible to create an election where you violate that criteria, but it doesn't mean that it violates it all the time. And when it says satisfies the voting method, that means that it never violates the fairness criteria. So for example, the plurality method always satisfies the majority criterion. So that's why we have satisfies. And pairwise comparisons always satisfies the Condorcet criterion. Okay, so this is just a little summary, and you don't have to memorize it or anything. Just we can try to look at it and see from this table, is there a criterion that none of my methods satisfy? Drop out. Yep. So a natural question would be, is there a method that satisfies the dropout criterion? And the answer is, yes, of course there is. We can always try to devise something that will satisfy an individual criteria. But we have this little roadblock called Arrow's Impossibility Theorem. And it says that there is no voting method, if you use preference ballots, that will always satisfy all 4 of the fairness criterion. Okay. So if we devise something that satisfies the dropout criterion, it would violate one of the other 3. So there is no voting method that can satisfy all 4. So this is pretty surprising, right? It means that it is inherently impossible to run a fair election all of the time. So there's a great quote about Arrow's Impossibility Theorem from our book. It says, no matter how hard we try, democracy will never have a perfectly fair voting method, and the potential for unfairness is built into every election. But this does not mean that every election is unfair, or that every voting method is equally bad. Nor does it mean that we should stop trying to improve the quality of our voting experience. So some methods are more fair than others, and we can always keep trying to improve the methods that we're using. It does mean, though, that we have to accept trade-offs in choosing one election method over another. Okay. For example, we might try to pick a voting method which would eliminate tactical or insincere voting. So a system in which tactical voting is impossible, that is, you never get a better result by voting insincerely, would be desirable. Here's another theorem named after 2 mathematicians. It says that this is basically impossible because there are only 2 kinds of systems that aren't vulnerable to tactical voting: a dictatorship, right, where you don't really get to vote, and random systems where we randomly choose who the winner of the election is. And that's not really an election, right? Yeah. So you can never eliminate tactical voting, but we could look for a system that's a little less vulnerable to tactical voting. So there are a number of other fairness criteria that have been proposed and discussed. We studied those 4 in depth. You're not going to be held responsible for these other ones, but just to give you an idea that there are other ones, other ways that we can measure the fairness of an election. So this first one's called the Condorcet loser criterion. So remember, Condorcet was a candidate. If a candidate wins all of its matchups, they should be the winner. This says if a candidate loses all of its matchups, they should not be the winner. Okay? If everyone would prefer anyone else, right, then that person should not be the winner of the election. And then we have a clone independence criterion. This one's a little bit harder. If you have two identical candidates running in the same race, the outcome of the race should not be affected. So if I had 4 people, A, B, C, and D, running, and I add a 5th, E, who is exactly the same as, say, candidate B. B and E are like twins, and everybody equally weights B and E in the same place. Okay, then adding that twin shouldn't change who we choose the winner to be. And then we have participation criterion. And this one says that not voting should not help your preferred choice win. Okay, so if not showing up to vote helps your desired outcome, that is a criterion that we don't like about elections. Okay. So for example, town meetings often require a quorum to hold a vote. And a quorum just means a certain percentage of the population or a certain percentage of the voters have to be there. It's, I think, it varies from town to town, but I think in Leverett it's like 5%. 5% of the town has to be there in order to hold a vote. So Ian actually told me this story, that he was at a town meeting and there was a proposal on the table that had the overwhelming support of the people present. But there were 2 or 3 people who were very, very against it. And when they called for a vote, these 2 or 3 people held it up and said, I want to make sure we have a quorum before we vote on this. And they were like 5 people short of a quorum. So many of the people there started calling their friend, their friends in town and said, come down here, we need a quorum to pass this thing. So 5 more people show up, they have a quorum. The 2 or 3 very vocal people against this particular proposal said, okay, we're leaving, to stop the vote, right? So their not voting kept this thing from passing that they didn't want to pass. So a participation criterion is something that we try to avoid, where not voting helps your preferred choice win. All right, so here's some overall conclusions from our study of election methods. No voting method is perfect. Pairwise comparisons may be the fairest. If you go back and look at this table, pairwise comparisons satisfies 3 of the 4 criteria. Everything else violates at least 2. So pairwise comparisons may be the fairest, but any of these other 3 can be easily justified based on the situation that we're using them in. A number of voting methods are improvements on the plurality system, though the plurality system is the one we use to elect most officials in the US, even though we have better or more fair systems. All right, so a brief biography of 2 important figures in voting theory. Condorcet is a really long name. He was a French mathematician, philosopher, early political scientist. He was involved in the French Revolution. He advocated free and equal public education, equal rights for women and minorities, first to propose a system involving pairwise comparisons. So we have the Condorcet Criterion. Sometimes the pairwise comparisons method is sometimes called Condorcet voting or Condorcet method. He was a strong opponent of Borda's system, which is the points. A leading figure in the French Revolution. He eventually fell into disfavor and died in prison. It is, because he believed in a lot of good things. Yeah, that is why, exactly. And then Kenneth Arrow, as in Arrow's Impossibility Theorem. This is the economist who proved that it is impossible to have a perfectly fair voting system. Economic theorist who's alive did his work in the 20th century. made fundamental contributions to numerous fields, but mostly equilibrium theory and welfare economics. And the discoverer of the impossibility theorem. So that summarizes our unit on voting. And to conclude your unit on voting, you have a project. Let's talk about it for a couple of minutes. There we go.